we go through these, I want you to recall what the parent functions are, okay, as well as to describe the transformation. This is from September and October, okay. In terms of transformations, they're coming back again, and we will see them at the end or last unit as well. So for number 1, x minus 2 squared, what is our parent function? Yep. X squared, which is our quadratic. All right. What direction is this moving in? Go ahead, Coop. It's moving to the right 2. So, whatever is inside parentheses, absolute value brackets, underneath the square root, that affects the x. It's the opposite of what you see. So if it's x minus 2, it's moving to the right. If we look at the one below, what's our parent function here? Lena. It is the absolute value function. What transformations are happening, Mia? Good. So again, inside is the opposite of what you see. So this whole graph is moving to the left. And since -4 is on the outside, you're moving down 4. Okay? Now if we look at the third one, y equals 2 times the square root of x plus 6. It is the square root function. Okay? Oops. What transformations are happening? Jason? Good. So the number in front represents the vertical stretch by 2. Okay? On the outside again, you're moving up 6 outside the brackets. Okay? Then we have our last one, a random function. Okay, random function. What is one transformation? The reflection because of the negative. James, what else? Vertical compression or shrink by 1/2. Excellent. Okay, what else? Coop? God bless you. We have left 2. And what else? Lift. And then we have down 10. Excellent, you guys. Okay, so our transformations have not changed. We are used to that. Okay, every function that we have seen, quadratics, square root, absolute value, and then random functions as well as cubics, all the transformations have been the same. I want you to keep those in mind when we get into our new function, the exponential function. All right? Our exponential growth and decay functions. Okay? The standard or the general form is y equals ab to the x. Okay? Where a can be your initial amount. Okay? Can be, unless there's movement. A is your initial amount, and B is what we're really going to focus on today. B is your growth or decay factor. The B value, which is attached to the X, is going to tell you if you have growth or decay. Okay? Some terminology we are familiar with. Domain and range we're going to look at again. Y-intercept we're going to identify. What is new is this word called asymptote. Okay? The asymptote means it's a boundary. Okay? Think of if you have a dog in an electric fence, right? What happens if you cross that electric fence? You get shocked, right? So that's what an asymptote is. You're getting very, very close to it, just never crossing it. Okay? Very, very close, but never crossing. Now, when there's no movement up or down, okay, your asymptote is going to be the same. Y equals 0. Okay? Your asymptote will be the same, y equals 0. That is going to be your standard automatic asymptote if there's no movement up or down. Okay? Before we identify if we have growth or decay, I want you to look at what these graphs look like. All right? Our graphs are exponential growth or decay. The growth function, an example, would be y equals 3 to the x. The b value that is attached to the exponent, if that is greater than 1, you have exponential growth. As you read this graph left to right, it's increasing. Okay? It's increasing. And if you notice, there's a dashed line here. That dashed line is your horizontal asymptote, which is y equals 0. Okay? That's your boundary line. And if you notice, some of you might be like, well, it's touching 0. It's not. It's getting very, very close to it. So if you were to graph this, say, in your calculator and looked at the table, your y values will get very, very small. Very, very, very small, but never hit 0. Okay? You also can determine the y-intercept, which is anytime we need to find the y-intercept, we substitute 0 in for x. Okay? Now, if you look at the one next to it, you have your exponential decay function. Okay? An example of exponential decay would be 1/3 to the x, meaning your b value is between 0 and 1. A fraction, 1/3, 1/4, 2/3. Okay? Meaning exponential decay. Your asymptote is still the same. Everything is identical, however, it's going in the opposite direction. It's decreasing. Okay, your y-intercept is still the same. Everything is still the same, but it's going in the decreasing direction. Okay, so these are the graphs we are going to graph shortly. But first, which we'll see this a lot in terms of word problems, we want to identify if it's growth or decay. So we look at the b value, which is always attached to the x. 1.15, is that greater than 1 or in between 0 and 1? Mia? Good. So the b value is greater than 1. So we have exponential growth. Now, if we wanted to find our y-intercept, okay, what is our x value for our y-intercept? 0, right? So if I wanted to find the y-intercept, I would plug in 0 for x, okay? 1.15 to the 0 is what? 1. 1 times 8,000, 8,000, which would be your y-intercept. Okay? Now, we are substituting 0 in. If you have no movement, left, right, up, or down, your y-intercept will automatically be 8,000. But I don't want you to get stuck on that. Because if it moves, if you have movement, if you automatically say 8,000, but my graph moved to the left or up 2, that is incorrect. Okay? So you could always check by substituting 0 in for x to find your y-intercept. Okay? All 4 of these have no movement, so you're going to notice a trend in terms of the y-intercept. But that's not always the case. Okay? So looking at number 2, we have our b value, 0.75. is that greater than 1 or between 0 and 1? Good. It would be between 0 and 1. And its decay. What is your y-intercept? Jason? Good. Your y-intercept is 0, 20. Right. Try 3 and 4. Number 3. What do we have? Growth or decay? Decay. And what is our y-intercept? 15. Good. Okay. For number 4, what do we have? Growth. Good. Because 5/2 is greater than 1. What is our y-intercept? Yeah? Good. Y-intercept is 0, 6. So for these particular, all 4 of those, the y-intercept in terms of word problems would be your starting value. Okay, eventually when we get there. Yeah?
Number like 8,000, are those A?
Uh-huh. Those are your A values. Yep, good. All right, so now we're going to get into graphing. Okay, this is just a chart to recall what transformations were or are since we just did that. Okay, as a little recap, but if you need to refer back to it, the ones that are starred you will not see, so we could just cross those guys out. But these are all the transformations we have seen. Okay, we have seen over and over and over again. All right. So you're going to notice that we're going to have different parent functions, okay? So if you have a graph, y equals 2 to the x, that is technically your parent function, okay, for this particular case. So anytime we're graphing a new function, we always start with a table of values. Okay? We always start with a table of values. And I use -2 to 2. We've done that since the beginning, okay? So if I have 2 to the -2nd, can I have a negative exponent? No. So where does that go? So 1 over 2 squared, which is 1/4. Okay. 2 to the -1st would be what? 1 over 2, good. 2 to the 0. 2 to the 1st. And 2 squared is 4. So we're going to go ahead and graph these, okay? You're going to notice our fractions are kind of hard to pinpoint where they are in the graph. Just make sure they're below 1, okay? So we have -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Okay? Just remember, put in bold letters if you need to, that if you have no movement left or right, it is not crossing that x-axis. Okay? Left or right, up and down. Mainly up or down. So, with each function, we're going to include 4 things. Okay? We are going to include identify domain, range, horizontal asymptote, and y-intercept. Those 4 things we are going to include on every graph. Okay? What is our domain? Excellent, Mia, good. -infinity to infinity. What would be our range? What's your first thought? Yeah, Jason.
Wait, you can't go to 0.
Okay, so what can you do? Okay. All right, it's okay. I like your thinking. Yeah, Jason.
Intercept is 1, so that be
Nope. What would our range be? Careful. our range, is our lowest y value. But we don't cross it, but can we include it since we don't know? Careful. Since we don't know the exact smallest value it could be. So we could use 0, right? We can use 0. However, why did I put parentheses instead of a bracket? Cooper? It's not exactly 0. We don't hit 0, okay? So, you guys, I loved how you started thinking it out. That's great, okay? When you are approaching 0, we don't know the exact value. We have no idea what it is. But we know it's approaching 0, so we could do 0, but we must include a parenthesis. There is no bracket, okay? What is our horizontal asymptote? Yeah. Y equals 0. And any time you're explaining your horizontal asymptote, it must be written as an equation. Yeah. It's a boundary line. So the horizontal asymptote can change, and we're going to see it in a little bit. But automatically, if there's no movement, it's y equals 0. Okay? So Mia brings up a good point. Your horizontal asymptote and your range should have the exact same number. 0, 0. Okay? Horizontal asymptote will start off or end your range. Okay? What is our y-intercept? 0, 1. Good. Okay. So 2 to the x would be considered a parent function because there's no movement to this. Now, what would change if my function was y equals 2 to the x plus 3? Careful. Careful. Okay, which one would it be? Why? I love it. Okay, but why was that your second option?
Because usually, like the old transformations, when you had a plus 3, like in parentheses, it means you go left. So I think it is the same.
Absolutely. It's with the x. It's with the x. So this transformation, when we have the x plus 3, you are moving to the left 3. Our parent function is still 2 to the x. So you are moving to the left 3. Now, here's one key piece of information. I do not want you to use these x values and plug them in. The reason is, if I was to plug in -2, what's -2 plus 3? 1. 2 to the first is 2. I will only see part of the graph. I will only see like these 3 points. I won't see the curve at all. So, key advice is to draw your parent function or your table of values, which we see here, and then move it to the left. So, what is changing, your x or your y? X. So, instead of -2, what is my new x value? If I'm moving to the left 3, -5. Okay? -1, if I'm moving to the left 3, where would I be? Instead of -1, where am I? -4.
So we don't actually do it out the right side.
You don't need to. 0. If I'm moving to the left, where would I be? -3, 1. So right now, the only thing changing is my x values. My y stays exactly the same. 1 now becomes -2, 2. 2 is now -1, 4. Okay? So if I stuck with the -2 and plugged it in, I will only see these 2 points. I won't see the entire graph. Right. Okay? So you won't even see those bottom 4 points, which are the key points of your graph. Okay? So now, in terms of domain range, horizontal asymptote, and y-intercept. Which stay the same? Well, domain and range both stay the same. What else would stay the same? Lift. Good. The horizontal asymptote is still y equals 0. Okay? So, if you're moving left or right, domain, range, horizontal asymptote are not affected. They stay the same as your parent function. However, your y-intercept, if we need to find that algebraically, here we need to, because we can't see it from our table of values. Our y-intercept, we substitute 0 in for what? X. Okay. If we substitute 0 in for x, we have 2 to the 0 plus 3. 0 plus 3 is 2 cubed, which is 8. So our y-intercept is 0, 8. Okay? Okay. It's not 6, it's 8. Okay, be careful. So you may have to find your y-intercept, especially if you're moving left, right, up, or down. Okay, your y-intercept will be different. Okay, let's try a few more. Okay, we have y equals 1/2 to the x. So, automatically looking at that, do we have growth or decay? Decay, good. All right. Starting with our table of values. Okay, -2, -1, 0, 1, and 2. So that means we have 1/2 to the -2nd. Careful. Yeah. 4. Because we have 1 to the -2nd, 2 to the -2nd. Can we have negative exponents? No, so both of those switch. Gives you 4. All right. 1/2 to the -1st would be 2. Good. 1/2 to the 0. 1/2. And then 1/4. Okay. -2, 4. Okay. So, this is our decay graph. Okay. It's just going in the opposite direction. What is our domain? Jason? Yeah. What would be our range? Go ahead. 0 to infinity. What is our horizontal asymptote? 0. And our y-intercept. So, even though it's a decay graph, are all 4 of those the same as the first graph we did? Yeah. Because 1/2 to the x is just a parent function. Okay, it's another type of parent function. It's a decay graph. So domain, range, horizontal asymptote, y-intercept all stay the same. So now what would change if I had 1/2 to the x plus 3? Or what's happening? Right. Excellent. So we have plus 3 on the outside, meaning we are moving up 3. So our original y values, we are adding 3 to them. Okay? So x stays the same. So we have -2, 7, -1, 5, 0, 4, 1, 3.5. Okay. All right. All right. So out of those 4 characteristics, domain, range, horizontal asymptote, and y-intercept, which one stays the same? Which is the only one? Domain. It's the only one that stays the same. What is my range? Careful, careful. 3 to infinity. Why is it 3 to infinity? Coop? Why does it get closer to 3? Yeah. Good. Yep. Our horizontal asymptote has now changed. Our horizontal asymptote is y equals 3. So your horizontal asymptote and your range will change if you are moving up or down. Okay? What is my new y-intercept? Good. 0, 4. Excellent. Okay? So again, notice range and horizontal asymptote have the same number. Okay? I want you guys to try some on your own. Number 1, 2, and 4. Okay? 1, 2, and 4. So the first one, 3 to the x. This is what we should have gotten, okay, in terms of table of values. So I want you to add the following. What is our domain? Mia? Okay, our range. Devin? 0 to infinity. Horizontal asymptote. Brian? Just y equals 0. Okay, is your asymptote. Okay, the 0 would be the same. What is our y-intercept, James? 0, 1. Okay, so very similar to what we saw in the previous problems. Okay, now looking at number 2, we moved up 2. Okay, we did move up 2. So what is our domain, Alina? Negative infinity to infinity. Lily B, what's our range? To infinity. Lily W, what's our horizontal asymptote? Y equals 2. And our y-intercept, Liv? 0, 3. Excellent. Okay. How many of you did get both of those correct? Nice job. Now looking at number 4, we move down 4. Okay. What is our domain? Josh? Good. Coop, what's our range? Good. -4 to infinity. Mia, horizontal asymptote? Y equals -4. And our y-intercept, what would we get? Jason? 3. 0, -3. Okay? So again, 1, 2, and 4 is what we saw. Okay, yeah, yeah. So 1 over 3, when you subtract 4, right? You have to rewrite this as 12 over 3, which is -11/3. Okay? So again, not to be exact with those, if you write them below 3, but above -3 and above -4, you're fine. Okay, with those, yeah. Yep. Okay, number 3. We have y equals -2 times 3 to the x. Okay, -2 times 3 to the x. So what is happening here? What are two things happening? Yeah. Reflection and what else? Brian? It's a stretch. Vertical stretch. Good. By 2. So, if we took our original values, 2, we have 1/9, third 1, 3, and 9. Okay. If we took our original values, what would we have to do to show the reflection and stretch? Okay, by doing what? You would multiply your original y values by -2. That takes care of the reflection and the stretch. So we would have -2/9, -2/3, -2, -6, and -18. Okay. Again, our x's just stay the same. Okay. So it's reflected and it is stretched. What would be our domain? Yep. What's up? Okay. -infinity to infinity. Good. What would be our range now? What would be our range? Careful, we have an arrow. Remember, range is your y value, so go bottom to top. -infinity to, Jason? 0. -infinity to 0. Now, why is it to 0? What's our horizontal asymptote? 0. What is our y-intercept? 0, -2. Okay. So the domain stays the same. The range changes. It flips because we have the reflection. So it's -infinity to 0. Horizontal asymptote is still the same. Okay. Any questions? We are going to have some practice. Okay. Starting on in this packet only. Page 4. Numbers 5 through 8. Page 5. 1 through 6. In all of these, I want you to include domain, range, go ahead, horizontal asymptote, and y-intercept, okay, for all of them so you could see, okay? So page 4, 5 through 8, a lot of this can be done in class time, okay? Page 5, 1 through 6, page 6, 7, 8, and 10. All right? Yep.